In this video, we are going to be learning about redox reactions. Just an introductory video to think about what it means to say that an oxidation reaction has taken place, a reduction reaction has taken place, how those two terms relate to the term redox reaction, which is sometimes used in chemistry, and finally, how we might break these redox reactions into half reactions to consider what we're seeing. So our learning goals will be to define these terms that I just mentioned and to do some practice problems where we determine whether or not a half reaction represents oxidation or reduction based on the location of the electrons in the reaction equation and the starting and ending change of the atom or the ion. So these are our learning goals for today. This is video 1 of a 2-part lesson. This video will mostly focus on thinking about these terms and doing one practice problem. The next video will have more practice problems where we look at a series of half reactions and decide whether or not they are oxidation or reduction. Let's get to it.
So chemical reactions always involve some changes in electrons. When we're talking about oxidation, we are talking about losing electrons. When we're talking about reduction, we are talking about gaining electrons. Oxidation and reduction have to happen together, which makes some sense because if one atom is losing electrons, another atom has to be gaining those same electrons, right? They have to go somewhere. So oxidation and reduction must always occur together. Reactions in which oxidation and reduction reactions are occurring at the same time are called redox reactions. Kind of stands for reduction oxidation. In this video, we will be observing half reactions, which only show one, either oxidation or reduction, process at a time to make things a little bit simpler. One way to remember, a quick mnemonic to remember oxidation versus reduction is oil rig. Stands for oxidation is losing electrons, reduction is gaining electrons.
To think about how half reactions can be viewed, think about this reaction between zinc and sulfur to form the ionic compound zinc sulfide. Zinc is a metal and sulfur is a nonmetal. In forming an ionic compound, zinc transfers 2 electrons to sulfur. So the full reaction, we might write zinc plus sulfur, Zn plus S, reacts to form ZnS, and if we were including Lewis dot structures, we might include them that way to show where the electrons are moving. So the full reaction might just be Zn plus S reacts to form ZnS. But if we actually break apart what's happening to zinc in terms of electrons and what's happening to sulfur in terms of electrons, we see that a redox reaction is occurring here. Now, in redox reactions, the two half reactions that we talk about do occur simultaneously. And so oftentimes we only look at a half reaction one at a time to help us think about what's happening to each atom or ion in the reaction. But we want to keep in mind that whenever we are saying that a substance is losing electrons, those electrons have to be going somewhere. Whenever we say that a substance is gaining electrons, those electrons have to be coming from somewhere. So we think about them all together, even though in this video we're going to be focusing mostly on looking at half reactions.
During oxidation, an atom or an ion loses electrons to become more positive. For example, neutral calcium becoming a calcium ion with a charge of 2+ is an example of calcium undergoing oxidation. It had to lose 2 electrons to go from being neutral to being positive. Reduction is the opposite, an atom or ion gaining electrons to become more negative. So the opposite process, a calcium ion becoming a neutral calcium atom, going from positive 2 charge to neutral by gaining 2 electrons would be reduction. It's called reduction even though it involves gaining electrons. That's a little bit confusing at first, but just remember electrons are negative. So when you gain electrons as an atom, you are reducing, lowering, making more negative your charge. And now when we think about how to add electrons to these reactions, right? If we are losing electrons from our starting point to our ending point, so neutral calcium being oxidized to become positive 2+ calcium ion, those 2 electrons are now no longer in the same species as the calcium ion. So I would write the 2 electrons as a product because after the oxidizing process, after the reaction, the 2 electrons are now free. They are no longer associated with the calcium atom. Opposite, with reduction, we are taking 2 free electrons from somewhere else and adding them to the calcium ion to reduce its charge, and make it neutral calcium. So in our oxidation example, we have a neutral atom becoming a positive ion plus 2 free electrons. It's losing those electrons. In reduction, we have the electrons on the reactant side. A positive ion is combining with 2 electrons to form a neutral atom. I say this because these are examples of half reactions in redox reactions. They are showing either oxidation or reduction just on its own, and they often include electrons. And so thinking about where the electrons are located is really useful. Let's look at another example where we're looking at lithium. So in this example, a neutral lithium atom is becoming a lithium ion with a charge of +1. This is an example of oxidation because the lithium ion is going from a charge of 0 to a charge of +1. It's becoming more positive, and it is losing an electron. The electrons are on the product side of this reaction because that represents losing an electron. The electron is no longer associated with the lithium atom. It is now separated from the lithium ion with that plus sign on the product side. If we look at the same example but in reverse, reducing a lithium ion to make it into a neutral lithium atom, we would take the lithium ion and the electron as our reactants, as our starting materials, and they would combine. The electron would be added to the lithium atom to become neutral. So in reduction, the electrons are on the reactant side to show the process of gaining electrons. So to sum up, oxidation is the loss of electrons, and reduction is the gain of electrons. In oxidation, an atom becomes more positive. In reduction, an atom becomes more negative or less positive, is another way to think about it. If we are looking at half reactions that involve electrons as reactants or products, when the electrons are on the product side, that will represent losing electrons or oxidation. If the electrons are on the reactant side, that represents gaining electrons or reduction. Let's do some practice problems. So take a look at each of the reaction equations below and think about which one represents oxidation. So which of these 4 reactions represents oxidation? There's 19 more seconds on the clock before I'll go over the answer. Pause the video if you need more time. So let's take a look option by option and think about what each of these answer choices is telling us in words. So then we'll decide whether or not we think one of them represents oxidation. In A, we're looking at neutral copper losing 2 electrons to become a positive 2+ ion. I know that this neutral copper is neutral because there is no upper right-hand number on this first copper here in the reactant side. That means that the charge is 0, so it's neutral. And I know that this neutral copper is losing 2 electrons in this process because the 2 free electrons are on the product side, right? The electrons were presumably part of this copper and then were lost and are now separated by that plus sign. In B, neutral copper is gaining 2 electrons to become a positive 2+ ion because the electrons are on the reactant side with the neutral copper. So it's got to be gaining there. Now, this doesn't really make sense because if copper gained 2 electrons, it wouldn't become a positive ion. Gaining electrons would make it negative. C, a positive 2+ ion loses 2 electrons to become neutral copper. Or D, a positive 2+ ion gains 2 electrons to become neutral copper. Now, the only answer choice on here that makes sense, both in terms of what's happening and in terms of fitting the definition of oxidation. A and C both describe losing electrons, so the answer's got to be either A or C. So then we just need to think about which one makes more sense. A positive 2+ ion, if it lost 2 electrons, that wouldn't be becoming neutral copper. If a positive 2+ ion lost 2 electrons, it would become a positive 4+ ion. However, if neutral copper lost 2 electrons, it would become a positive 2 plus ion. So that's the only answer choice here that really makes sense, knowing what we know about electrons.
Let's look at another example. Which reaction equation represents reduction? We're looking at the same options as before, so we're still looking at neutral copper losing 2 electrons to becoming a positive 2 ion in the first option. In B, we're looking at neutral copper gaining 2 electrons to become a positive 2 plus ion. In C, we're looking at a positive 2 plus ion losing 2 electrons to become neutral copper. And in D, we're looking at a positive 2 plus ion gaining 2 electrons to become neutral copper. So take a moment to think about which of these represents reduction. Pause the video if you need more time. So we know that reduction involves gaining electrons. So we have to have the electrons on the reactant side or on the left side of the arrow to represent the atom or ion gaining electrons, combining with the electrons to become one overall unit in the products. So in this case, D would be my answer, because the only two options that show electrons as reactants, gaining electrons, are B and D. But B doesn't make sense. If neutral copper gained 2 electrons, it would not become a positive 2 ion. It would become a negative 2 ion because electrons are negative. So it must be that a positive 2 ion gains 2 electrons to become neutral copper, because positive 2 charge plus 2 electrons gives me 0 charge, neutral charge. Let's check back in on our learning goals. Remember, there's a second part of this video series that will help you to do some more practice problems, giving you a chance to take a look at multiple choice question, think about which answer you'd pick, and then see me going over the answer. So if you still would like some more practice, make sure you look out for that second video. Nice job today.